Hello and welcome. In this part we're going to learn about the product rule, which is a rule that will help us take the derivative where you have a function that's the product of two smaller functions. So let's check out the notes to get started. Here we're looking at the product rule, and I think it helps to look at an example first. So in example 8, we've got this function y equals 1 over x times x squared plus e to the x. So when you see that times right there, that's going to help you think about the product rule. Whenever you're taking the derivative of the product of two functions, you're going to use the product rule. So what does the product rule say? It says to take the derivative of the product of these two functions, you want to take the first function times the derivative of the second plus the derivative of the first times the second. So that's, in a nutshell, what it's saying. A shorthand version of it, without all the parentheses x's, would look something like this. F times g prime, so the derivative of f times g, is equal to f times the derivative of g plus the derivative of f times g. So first times derivative of second plus second times plus derivative of first times the second. So let's apply that to example 8. In example 8, the f is 1 over x. The g is x squared plus e to the x. And so if I want to find dy dx, which remember means the derivative of y with respect to x, then following the product rule, I want to take f, which is 1 over x, times the derivative of g, so the derivative of x squared plus e to the x, plus the derivative of the first function, so derivative of 1 over x, times the second function. So that's x squared plus e to the x. Just to follow what's going on here, 1 over x is f. The derivative here is g prime. And then you have plus f prime times g. So it's pretty simple to use. Now all you have to do is take the derivatives of the smaller functions. And this is what the product rule is doing. It's taking the derivative of a more complicated function and breaking it down into derivatives of smaller functions that hopefully you can handle. So let's take the derivative of x squared plus e to the x. So what would that be? If you said 2x plus e to the x, then that's correct. So to take the derivative of x squared, you want to use the power rule. So the 2 multiplies in front, and you subtract 1 from the exponent to get an exponent of 1. Then the derivative of e to the x is just e to the x. Then we'll have a plus. And for the derivative of 1 over x, for the derivative of 1 over x, technical difficulties, we actually did that in a previous example, and we got negative 1 over x squared. Here, just to remember how that works, you would take the 1 over x, rewrite it as x to the negative 1, and then use the power rule. So then we have times x squared plus e to the x. Remember g, the second function, we're leaving alone for the second part here. So then I think the only thing left to do is really simplify. So let's go ahead and simplify. We'll distribute the 1 over x, and we'll get 2 plus e to the x over x. So we're distributing that 1 over x into the 2x and the e to the x. And then do the same thing with the negative 1 over x squared. Distribute it, and you'll get plus negative 1 minus e to the x over x squared. One last thing to simplify is we have a couple of like terms that we can combine. We can take the 2 and combine it with the negative 1. And when you combine those, you get 1 plus e to the x over x minus e to the x over x squared. And there we have our answer. All right, so let's go ahead and try the product rule one more time on example 9. So here we have two functions that are multiplied to each other. X squared plus 1, which is like our f, x cubed plus 3, which is like our g. And so what we could do is use the product rule. We have the product of two functions, so we can use the product rule. So now we've got dy dx equals the first function, f, times the derivative of the second function. So I'll write d dx of x cubed plus 3 plus the derivative of the first function, so d dx of x squared plus 1, times the second, x cubed plus 3. Now, what I'm doing here is I'm procrastinating and taking the derivative of those littler functions. I could just go ahead and take the derivative of x cubed plus 3, and that's totally fine. That's eventually what you want to do. But since we're just learning the product rule, I wanted to show you step by step how you would do it. So now let's go ahead and take the derivative of x cubed plus 3, which should be 3x squared. Yep. That was a little weird, sorry. And then what's the derivative of x squared plus 1? If you said 2x, that's correct. Remember that in both of these derivatives, the derivative of the constant term is 0. So those constant terms go away. Then we have times x cubed plus 3. Now we can do a little bit of work to simplify. We can distribute the 3x squared into the x squared and the 1. Do the same thing with the 2x. So you'll get 3x to the 4th plus 3x squared plus 2x to the 4th plus 6x. And combine like terms. So here we've got a 3x to the 4th and a 2x to the 4th. And it looks like those are the only like terms. So we get 5x to the 4th plus 3x squared plus 6x. And so that would be your answer in a nice simplified form. Now, having gone through this example using the product rule, you should know that there is an easier way to do this problem, which is to take the two functions and multiply them together first before you take the derivative. Now, you can't always do this, and a lot of the times when you're using the product rule, you won't be able to do this. But in the case of a polynomial, you can take the polynomial and the two polynomials and multiply them together. Just do a big giant FOIL and multiply the two functions together, polynomials together. So off to the side here, I'm just going to write another way that you could do this. So, or pre-process y by multiplying it out. So here, what I'm going to do is take x squared and multiply it to the x cubed and the 3. I'm going to take the 1 and multiply it to the x cubed and the 3. And when I do that, I get x to the 5th plus 3x squared plus x to the 3rd plus 3. And now I can take the derivative term by term. So I don't have to use the product rule, which, as nice as it is, can get a little bit more complicated. So we have 5x to the 4th plus 6x plus 3x squared, and the derivative of 3 is just 0. And that's the same thing that we got over here. So in this case, product rule is probably overkill because we can pre-process the function and make it a lot easier to take the derivative of it. All right, in the next part, we're going to look at the quotient rule, which will tell you how to take the derivative of the quotient of two functions, and you can take a peek at it down below there. So thanks for watching, and see you in the next video.